I'm getting ready to start it right now. You're good.
All right. Well, good morning, everyone. Let me start by introducing myself. I always forget to do that, so I had to add a slide for this specific purpose. Some stuff that pops up. So I thought I'd introduce myself because I'm not sure if everybody knows me here, but I wanted to show that I have a little bit of Informix background. So you see the several books that I've participated in, and I've also written books on Informix application development and things about IBM streams. Recently, over the last several years, I've been working more in the data science aspect of data. And you can see here, I put a URL, youtube.com/c/bite-size data science. And I will reference that a few times in the presentation just because I want to make sure that people have a chance to to get more background information, more information on how to get better at data science. Data science is very important in the world today, and I strongly believe that people that have a strong data background can get into data science, and it doesn't take that much. So I went through that effort, and my Bite-Size Data Science channel tries to take you through the steps to learn stuff so you can at least participate in conversations related to data science and contribute to what the team needs to get to a solution. So let's get into the subject of this presentation, which is talking about time series and using COVID as an example of that. So when we talk about time series, let's say I have a restaurant that sold 87 meals today. Is it good or bad? So what do you think? Is it good for this restaurant? We don't know. We would have to know more about what the restaurant does normally. And so really, we need to understand if how much did they sell yesterday, how much they sell on Wednesday last week, and how much did they sell on Wednesdays, maybe last year, the same time of the year, things like that. And so that's why time series is important, because we can see a trend. To make it more, I watched yesterday the presentation from Art Kegel, and that reminded me that maybe I should have used a different example. For example, if I say your cash hit ratio is at 95%, is it good or bad? Well, it depends, because basically if you've had that type of ratio over the last month and everything is fine, then maybe if you're starting to have issues, you should look somewhere else. So basically, time series allows you to see trends in your data to figure out what may happen next, where you're leading, and things like that. So so let's look at what time series are, and I'm going to do that very quickly through a very simple distinction here. So basically, you have two types of time series. So time series are series of values ordered by time, and so they can be either regular or irregular. So if they are regular, that means that they are at a specific interval. For example, in the case of what we'll be looking at today, we'll be looking at COVID data that is a daily reading. And so that means my time series is one value every day. However, you can have other time series that are irregular, which means that the values can come in at any time. For example, if I monitor a door that gets into a secure area, I could monitor the fact that the door is closed or open. And so I don't need to take readings every 5 seconds to say, yes, the door is closed, and another 5 seconds, as the door is closed again. I can just find out when the state changes. And so the door may be closed for hours, and then all of a sudden it's open for 5, 10, 15 seconds, and then it's closed again. And so that allows you to save data and save your data and save a lot of space in terms of storage because you can just record the events. So in the case of the door close or open, maybe then you want to be a little bit more specific in your analysis that says, give me the time the door was open and for how long, and then that can indicate that the door was open for a little bit too long, which could indicate that somebody that should not have had access can get in there. But the bottom line is when you do real analysis of time series, you'll have to convert your irregular time series to regular time series to be able to do the analysis of trends and things like that. So in what we'll be looking at today, we'll be looking at COVID-19 data, and that's something I've done on my channel. So you can, my YouTube channel, where you can find additional videos on that. And the data comes from data.cdc.com. But to be able to access that, I used what's called the Socrata API. And you'll see it in the example in a few minutes. And by the way, the notebook that I'll be using, I can make it available to everybody. So I can send it to Rhonda, and then she can then make it available to everyone. I do the same thing on my channel where I use notebooks. I make the notebooks available there too. And that's a good way to learn how to do different things. And so the importance of the Socrata API is because it's an API that was created as part of the Open Government Initiative. And you don't only access data from the CDC, but you can access data from all different government agencies. It can be federal, it can be state, and there are multiple countries that participate into that. And you can get a list of the domains that are available, and with each domain, what are the data sets that are available. And I have, again, some videos on my channel that will give you information on how to use that, how to get to these different data sets. And that can be very useful because no matter what you're doing, external data can be useful to help run your business. For example, if you're an insurance company, you may want, and you want to rate the insurance rates in the Chicago area, you may want to be able to go look at the accidents and the trends in accidents in the area where most of the accidents occur in that Chicago area to figure out what rates you want. So that we'll be using COVID, a very simple example in what we'll be doing in terms of how you get to understand the data and how you can get some insights, very simple insights. One more thing about COVID data and time series in general, about storing it. So the thing is, you can go read the data through that Socrata API, but if you want to reuse the data multiple times, always downloading the data from the CDC site can be cumbersome, can take time, and especially when you have an anonymous account, you're limited on how much data you're allowed to download. And so it would be much better to store that locally. And some people would say, well, let's store it in just a file. Personally, because of my background, having done a lot with databases, I much prefer to use databases to store my data, because then I can simply go read through that API, read the newer data that since the last time I read them, I read the data, and then insert it into my database. And if it's in the database, I'm able to join multiple data sets together to get a better insights, which is not something we'll do today. And of course, when we talk about time series, you should consider the Informix TimeSeries if you're planning to do a lot of analysis, time series analysis. In the case of COVID, there are very limited amount of data, because as you'll see in a minute. And so let's switch right away and go into the notebook and start what we'll be doing. And so here I have what we call a project within Watson Studio, or now called the Cloud Pak for Data as a Service. And I have some data that I've stored and some notebooks. And I'll be using this notebooks here, Informix Conference, November 5 to 7. And so I opened the notebook. By the way, if you don't have, if you can create a free account on the data platform.cloud.ibm.com and be able to use my notebook here, there, if you want to. It's self-contained, so I don't use other capabilities as part of Watson Studio. And so you could also install an open source product that allows you to run notebooks on your own PC and run it there. So I'm not here to push this platform, despite the fact that really I use it all the time, and there's a lot of other capabilities that makes it interesting to use. So I will first, I ran my notebook yesterday just to make sure it still works, and hopefully it will still work today. So the language I'm using, and I will give multiple descriptions because I'm assuming that some people here are not familiar with notebooks, not familiar necessarily with the Python language. And so I will give a little bit more description of what's happening in the environment. So a notebook is made up of cells. And you see here, the top one here, it's called a markdown cell that allows me to put documentation in there. And you see I put a title, and I could even say, I'm going to put some bullets. And then when I execute the cell, then I have a bullet. And so I have formatting capabilities that allows me to document the executable code. And then you have this cell here that's called a code cell. You see it in the top, that allows me to execute the code. And in this case, I'm just setting up my environment. And so, and very quickly, I'll be using the population by state. Basically, I'll use the COVID data by state. And so I'll need the population by state, and you'll see that in a few minutes. So when I talked about the Socrata API, you can see here that I simply have to install that library. A pip is an installer that goes and goes to a specific site and finds the library I want to install, and then I import it. And so that's one way to install it within your environment. You could also install it within the environment itself, and that's something I'm not showing in here. So it would be there by default, so you would not need to do this installation. But it's still pretty quick, so that's not a problem here. And so I've done my search, and I found out that the data I want to use is from data.cdc.gov. And again, you can go list through the Socrata API. You're able to go list all the domains that are available and all the data sets that are in each domain. And so I'm creating a client interface here, and you see here, requests made without the app token, meaning that I'm basically an anonymous user. I have limits in terms of what can be used. The first thing I want to do is find out what are the data sets that are in here available from the CDC that talk about COVID. And the key to what I'm doing here is this line that is actually relatively advanced, that deals with list. And basically what I'm saying is, in the result that I'll be getting here from the client's the data set, look at the name, and in there, if there's if you find COVID, then select it, and then from that result list, just list the resources. That's basically what I'm doing here. And so here you can see that I have 654 data sets total as part of the CDC, and 74 of them talk about COVID. And so I'll be using one specific data set, as we'll see in a minute, but basically you can have a lot of different analysis you can do with that. And we see that often on the news, where they'll talk about the different trends, either by state, by age, by even by county and things like that. And so this is where they can get their data through these 74 data sets that are available. So now what I'm going to do is extract the information related to the specific data set that I want, that is United States COVID-19 cases and death by state over time. And then I want to find out what data is available in there, and I can list the column names and their types, and I can go further by extracting what's called the metadata out of that data set. And I'm just listing part of it, but basically that gives a better idea, where I have the column name, the type, how many non-null values I have in that data set, and the description of the field. So I see that I have 37,320 records, but in some fields, I have null values where the number of values goes down. And so then that may indicate that in some cases, not in this case particularly, that may indicate that this is not a field that I should rely on to be able to do analysis. So let's read the record. When I'm doing this is reading through what's called a pandas data frame. And again, we see the number of records, 37,320, which match with the maximum value that I have here in my metadata. I use what's called a PD, which is Panda Data Frame, which allows me to have look at it a little bit like a table, in-memory table that allows you to then manipulate the data and do things with it. If you were to take the data instead of reading it from the CDC site and you had it instead in an Informix database, there's several of the steps that I'm doing here. I read the records. I had to loop because there's a 10,000 records limit. So I had to loop multiple times to get all my data. Then I have to change my data types because by default, when I read that data, it's all characters. So I had to change it to either float, date, time. Well, that's basically what I've been using, float and date time in this case. And so then I'm ready to do something with my data. But with what I'll be doing here, I don't need all the records. I could have limited the number of the columns that I have as part of my reading the entire records, but I didn't because I want to make sure that you could see that all the different values that we have in here. And so you see there's a difference between the submission date and, for example, when that record was created. And so you see the record for January 22nd, 2020 was added March 26th. So that gives you an indication that that's when the CDC really decided that, okay, we need to get more serious about the Arkansas data. But maybe in that case is because Arkansas didn't have that data available for the CDC. And so that gives an indication again of when the data becomes really available and that there are changes that occur over time. So in my case, I want to limit the number of records that I want to use to a few columns. And the first thing I want to do is look at my data visually. And to do that, I'm using, again, I'm manipulating through the data frames, the pandas data frame, and I'm using matplotlib to be able to display the data. And so what we have here is I'm comparing Texas and Oregon. And you see Oregon, by the way, that's where I live, and that's a background you see here where I applied actually some AI to a picture to give it more of a Van Gogh type style at the back. And so you see here that this first graph tells me that Oregon has a lot less cases, has had a lot less cases over time than Texas. But this is misleading because the Texas population is much higher, so I cannot really compare it that way. So I wanted to show you that it's easy to make mistakes and say, well, let's compare the data. Well, you have to really look at the origin of the data, what the data represents, to be able to get to the point where you say, okay, here's how I can compare one state to another. So let me do a couple more steps here where I extract my my data, where I aggregate my data by to be able to get my US population. And then what I'm doing is getting a value that will allow me to provide the number of cases by 100,000 residents. And so I'm extracting additional states here. And so now if I do a per capita for multiple states, and I have a list here, Arkansas, Arizona, California, Florida, Hawaii, Kentucky, Michigan, Mississippi, North Dakota. So as you can see, I memorized even all the code because I had to do that over time. So if I look at the result here, I'm using a loop to be able to provide multiple graphs at the same time. So as you can see, that's very few lines of code that gives me a lot of information. And what we see here is basically a per capita comparison. Let's say the first graph for Arkansas, which is in blue, compared to the US average. So in the US, you see that Arkansas started low, and you can see at the beginning of the pandemic, we can see that really New York was the biggest. Well, New York, I guess Washington and New York were the first two big states to be really hit. And you see that Arkansas was low, but then eventually they went higher than the average. Then they took control around early December. They started taking control of their cases, and it went back down below the average. And you can see that because, of course, these are values per 100,000, so their number of cases really went down. But then after that, for some reason that I won't get into because everybody knows what's happening on the news about vaccination, etc., we can see that the national average is going down, but Arkansas has been going up. This graph is actually very noisy, as you can see, because these are daily values that keep changing. And so we see these different graphs for different states, Arkansas, Arizona, California, and you see California really then started taking control here and still below the average. Florida went way up in July, August, September, and now they're actually below average, which is surprising. As a quick aside, there were some questions about the quality of their data, so I'm not sure how much we can rely on that, how much they provided. So I have these graphs for all these states that kind of give me the different trends. And what's nice about it is now I can look at, for example, since I live in Oregon, I can say, okay, Oregon stayed below average, but then started going above average. And now it's kind of staying around the average, but it's not doing as good as it should be. Okay, so now if instead of looking at all that noisy data that is daily, I can apply what's called a moving average. And what that does, it's taking the last 7 values and doing an average of these last 7 values instead of just showing the last value. And that provides a nicer curve that allows you to really see the trends. And so in my case here, you can see the moving average in orange, and it's much easier to see if it goes up or down because instead of having that noisy data that goes up high one day, the next day it's low, and then it's high, and that could be simply because of the way the data was reported, where if I keep the average, I can see that, yes, now over the month of September, since the beginning of September, the trend in Oregon has been going down. So that gives us some insight, a better insight by doing an average. And I can do the same thing now that I can do per capita comparison and averages. I can now look at multiple states at the same time. And you can see that you can see basically some of the peaks here, like Florida was really high in mid-July last year, and went pretty high here in July, August to September this year. But then you see, for example, the that's Arkansas, that people were talking about a lot at one time in the beginning of January. And so some of the peaks that you hear about when people talk about the different states, you can see them here on a graph, and you can compare the different states and compare it also with, like I have here, the US average. And so that's how you can get an idea of how one state does compare to another and what is the trend going forward with the different states. In fact, I have all the data since the beginning, and maybe it would make more sense to instead look at the data for the last 2 months, for example, to give because then the range of values would not go between 0 and 120 per 100,000 people, but would then vary most likely between at least 20 and 120, so that the graph would be a little bit more precise in terms of being able to see what's happening. And you see that Mississippi was not doing very well back in August, but has had a big drop since. Let's see here. So now I can do the same thing I did earlier for the graphs, but instead using the graphs where I compare the US average with it for the different states, but instead now I'm using the moving average. And with that moving average, you're really able to see that you see that you better see the trends both for the national average and for the specific state. And note, by the way, that I have Arkansas here. Look at the values, varies between 0 and 175, where, for example, if I go to California just below, it varies between 0 and 120. And so you can't superpose the two graphs together and say, okay, well, here's the curve for one, here's the curve for the other. And because in terms of number of cases per 100,000, they're not, you can't compare the graphs one to the other, but you can look at the different trends, that where are the peaks for the different states. And you can see that, for example, the trend with California, you look at the peak here, and you look at this one here below for Hawaii, for the national average, you look at that peak and it looks very similar to California. So you see that back in late 2020 and early 2021, the number of cases in California had a big impact on the national average. And so because it has the same shape of the curve. And so all that to say that you can look at all this data and compare and have an idea of where things are going by looking at the different curves. We'll go a little further in a minute in terms of what can be done. But basically, by having that moving average, you could then look at basically a slope of your data to predict what will happen next. And so you see the national average is going down. So most likely the reading that we'll get today, these are daily readings, so the reading we'll get later today, at the end of today, would show a lower value as part of the moving average. And so we're going down. Another way to look at trends, thinking about moving average, and that's something that is being used as a basic tool in stock trends, is to look at multiple moving averages. So for example, here I have a 7-day moving average, which is kind of nice because it really covers 1 week. So the value for that, each value that I'm collecting is really comparable to the previous value, because the previous value also uses a full week. However, I could use another moving average called, let's say, for example, I could use a 30-day moving average. And there are ways to look at basically when you see where the 30-day moving average and the 7-day moving average cross. If they cross on a way down, that means the trend is going down. If they cross on the way up, that means the trend is really going up, going further. So there are additional analysis you can do just using moving averages. And by the way, all these moving averages, you can do them directly within the Informix TimeSeries analysis. And so instead of bringing all your data within your notebook, in my case, or within your application, however you look at your data, you could move the processing into the database and just get the result. And that should give you some speed improvement right there, because you're taking advantage of the optimization of data manipulation as part of the Informix TimeSeries. And so that's something to consider. In the case of COVID, as I said earlier, we have very few data points, even though we're a year and a half within that pandemic in terms of data. we had only, what, 32,000 data points. So that's not a big data set. So you have a choice then to decide how you want to store it. If you do a lot of time series analysis, I would still consider moving it into a Informix TimeSeries storage, and then have the virtual tables on top of it to make it easier to access it for people that want to look at it as relational data. And you can also even create views that would then make the result of time series calculations that are done within the database look at the result like if it was a relational table, which then makes it easier for tools like a notebook to read the data, because it doesn't need to know that we have specialized storage behind the scene. We simply have a normal storage, and I'm simply reading my results. So something to consider. Again, for COVID, in this case, 32,000 records is not a lot, but if you want to go deeper in the analysis, you may download a dozen different data sets for COVID. And if you, for example, decide to, instead of looking at states, which you have 50 states, look at counties, then all of a sudden your number of data sets, a number of records goes much higher, because it goes from 50 different readings per day to, what did I hear? Something like 300 something readings per day. So that gives you a factor of six times number of records, which still is not that big, but depending on the analysis you're doing, using time series makes sense. Okay, so when we talk about time series analysis, the moving average was fine. There's no problem there. Whatever data you have, and of course you have to have regular time series, because if it was irregular, then the average would not make sense, because it doesn't. There's no repeating value, so you don't really have an idea of what the trend is. But in our case, again, we're dealing with regular time series. So in time series analysis, you'll hear about autoregression, and you'll hear about moving average, which is different from what I've showed you as more of a, well, what I call the moving average. And then you'll hear about a mix of both, of autoregression and moving average. So you'll hear about ARMA, which is autoregression moving average. And you'll also hear about ARIMA, which is autoregressive that should be integrated moving average. And that's basically doing a integration of your data to be able to make it more stationary, if I remember right. It's for some reason it's skips my mind right now. But one thing that is important is to find out if, whoops, I shouldn't have done that. Okay, if your time series is stationary, and the reason for that is if it's not stationary, the autoregression and moving average won't really make any sense. And so that's why in my case, I focus mainly here on my my 7-day moving average that I had there to see the trends. And so the first thing I want to do before I want to apply autoregression or the moving average is to figure out if the time series is stationary. And so in our case here, when I first created this, the time series was not stationary. So I could not go any further. And now it says the total time series is stationary within a 5% margin. And you see in my calculation, I have within a 1% margin and 5% margin. Of course, a 1% margin would make a lot more sense. So if the time series is stationary, then the other things you may want to look at is for seasonality. And so when we talk about seasonality, which it means that you could have repeating patterns. So for example, if you look at lawnmower sales, you'll probably see that people buy lawnmowers a lot more often, either in spring or even in the fall. But in January, there's not many lawnmowers that are being sold. And so stores don't usually keep that many lawnmowers. And so you can see a seasonality there. So in the case of our COVID data, the fact that now it shows that there's a certain station, it's stationary as a 5% margin for the entire data set, that indicates that now I could do some additional analysis of applying, like I said, autoregression and ARMA or ARIMA to try to predict future values. And the different analysis you can do in the time series will tell you how many values you can predict in advance. And from what I've seen, there are not that many values you can predict from a little bit in advance. And so by looking instead at the simple analysis that we've done here and looking at the trends, you could probably do the same. Like here, for example, you saw a big national trend in January that went down dramatically until almost March. And even then it started going down a little bit. And so by using multiple moving averages, you could then see when in the curve where it would have a tendency to go up. So probably around here, you could then indicate, it could then indicate that by looking at multiple moving averages at the same time, that there's a trend that we're going to go, we're on an upswing, and then back to here, maybe you'd see, okay, we're back on a downswing. And then again here, before the upswing really starts, you could kind of predict that, okay, it looks like we're on an upswing. And then you see the trend that goes up really dramatically. And so just looking at that simple data of monthly COVID cases, not monthly, daily COVID cases per state is not sufficient. You would need to look at trends in vaccination and trends in different age groups and so on and so forth, and even age distribution within states and things like that. And so there's a ton of different analysis that can be done on the COVID data, but you can see that, again, to do that analysis, very basic analysis still gives you some good insights, especially when you have good visualization of your data. So to come back to my theme at the beginning, talking about my YouTube channel, I believe that people that deal with data, and of course at an Informix conference here, everybody is a data expert. Everybody knows how to manipulate data. Everybody knows what data is and what it can give you. And so by getting some basic knowledge on data science, understanding what a moving average here is in terms of time series, understanding the importance of time series because any trend analysis involves a time series, and understanding different basic concepts, math concepts that I'm sure you learned in high school and forgot because you couldn't see why you would have to worry about a bell curve, for example, the normal curve and things like that. Just by refreshing this knowledge and acquiring a little bit of vocabulary, you could then be a valuable member of a data science team without being classified as a data scientist, and that can get you the foot in the door into these data science projects. And based on what you want to do in the future, you can then decide to learn more and more as you go forward. And that's basically what I try to do with my YouTube channel. If you start way from the beginning, I have something like 85 videos in there that gives you some good insights on the basic concepts that you need to be aware of, and programming languages like Python, that it's what languages are important, what the different technologies that are important, and you have the base, the data knowledge base to be able to move forward very quickly to participate in these projects and being able to express your opinion on different things. So this is what I wanted to show you this morning. Hopefully you got something out of what time series are about, what you have to do when you want to analyze some data, visualization, and what notebooks are, and also a little bit of concepts of the Python language, and the fact that there's additional libraries like Pandas, data frames, and Matplotlib that can be used to manipulate the data and show visualization. And as I said earlier, this data, this notebook, I can make this notebook available to anyone. I'll make sure that Rhonda gets a copy of it so she can post it with the presentation on the site. I'm assuming that the presentations will be posted. And with that, I'm ready for questions.
Thanks, Jacques. See if anybody has any questions for you. I am not seeing any questions right now. Oh, there we go. How can I get the notebook?
Well, you can, well, for people that want a notebook, I mean, some people know me, they know where to find me, but basically, let me write it down, actually. I'm going to go here in the notebook, get into my, just so you see it. That's my email address. So you can email me, jacquesr@us@ibm.com. And the reason I write it is because a lot of people have problems with my first name. Either they forget the C or they forget the S. So now you have the email. Email me, just say, can I get the notebook from your presentation, and I'll know what you're talking about, and I'll send it to you. It comes in as a JSON document, so the only way for you to read it is to either use Watson Studio, as I've used here, or install something on your laptop that gives you notebook capabilities, which is pretty easy to find. Just do a Google search and you'll find it easily. So with that, you can get my my notebook. I'll be able to send you my notebook. And then, by the way, the nice thing that I guess I got a little bit paranoid at one time in terms of I'll remove that now. So I'm sure you wrote it down. Secure the cell. One of the main reason I wanted to look at the trends is to find out if it was safe for me to let's see, where is it, Michigan? If it was safe for me to go around, you know, different places in Oregon. But then I have two kids that live in other states, and one of them lives in Arizona. So I wanted to make sure that I could keep track of what's happening in Arizona if I want to visit. So as you can see, around December, well, let's say between December 2020 and let's say February 2021, definitively I didn't want to go to actually I should look at the other graph here. I didn't want to go to Arizona because it was way above the average, but then when it moved below the average, then I can say, well, it's not that bad and maybe I can go visit. And so maybe for people that want a notebook, if that just gives you that, being able to find out what's happening in different states, that would be fun for you. Okay, any other questions before we close?
Okay, Jacques, looks good. Thanks again for doing this presentation for us. It was very interesting. And I'm going to stop the recording now.
Thank you, and have a good day.